Hello, my name's Nate, and today I'll be showing you the steps needed to solve the blocked billboard problem from the 2017 USACO programming competition. So, please enjoy the video and consider subscribing if you have the time to do so. So, during long milking sessions, Bessie the cow likes to stare out of the window of her barn at two huge rectangular billboards across the street advertising Farmer Alex's amazingly appetizing alfalfa and Farmer Greg's great grain. One day, as Bessie's staring out of the window, she's alarmed to see a huge rectangular truck parking across the street, and she is very concerned that the truck will block her view of the billboards. So, our task is given the coordinates of the bottom left corner and the top right corner of the two billboards and the truck, output the total area of the billboards that is still visible to Bessie. So all we have to do is add the areas of the billboards together and then subtract the area of the billboards that is intersecting with the truck. But how do we get the area of the billboards that is intersecting with the truck? Well, to make it easier to understand, let's first hide the second billboard. To get the area of intersection between the first billboard and the truck, we must find the length and width of this square right here. And to do that, I'm going to show you an interesting little trick. Take a look at these two lines, A to B and C to D. To find the length of the intersection between these two lines, we can use this formula. And this formula will give us 2, which is the length between this and this. Don't believe me? Let's test it out. We can start by substituting B for 8, D for 17, A for 0, and C for 6. Now, the reason we have this max between 0 and the result of this is because if the result of this is negative, then that would mean that they are not intersecting, which means that the intersecting area is 0. And now all that's left to do is to apply that trick to the lengths of the two rectangles and the widths of the two rectangles, and then multiply the results together to get the intersection area. Right, now that we understand the logic behind the solution, let's actually code it up. So include bit/stdc++.h. This header file includes almost everything needed for competitive programming. Let's use the namespace std so we don't have to type std multiple times. And the main function. Don't forget to return 0. Now, I'm going to declare a struct called rectangle, which is just a rectangle, so it stores the bottom left corner of the rectangle, so int x1, y1. Let me just add a comment right here, so bottom left corner, and the other one, which is the top right corner, so int x2, y2, top right corner. There we go. Perfect. Now what the struct is going to do is it's just going to keep us organized. So I don't have to declare something like int billboard 1 x1. Like, that would be horrible, because then I would have to do 16 of these variables, and it's just going to be a big mess. So I declared a struct to solve that problem. So rectangle billboard 1, so billboard 1 rectangle billboard 2, and the other rectangle, which is the truck. Perfect. And now we're just gonna accept the input from the user, so cin billboard 1 dot x1 billboard 1 dot y1 billboard 1 dot x2 billboard 1 dot y2. Perfect. And now just repeat this for the truck, for the second billboard and then the truck. The order matters because we have to send it to an online judgment program thingy. Truck. You know what? I'm just not gonna type it out. I'm just gonna. Oh, come on. Okay, I'm gonna paste this. Get the truck. Bam. Perfect. Now for the magic. Let's first declare two functions. So the first function is just area, and it accepts a rectangle. We'll call it R. You can call it anything you want. And it just returns the area of R. So how do we get the area of R? Good question. we're going to need the length of r and the width of r and multiply them together. So int width, let's do length first. Int length is equal to r dot x2 minus r dot x1. Now, this is just going to be like the end point of the length minus the starting point of the length, which is going to give us the length. Now, x2 is always going to be more than x1, but just in case, I like to add an absolute when I'm working with areas. Just in case, so that it doesn't become negative. It probably won't be negative anyway, but just in case. Now we just do width is equal to the absolute of r dot y2 minus r dot y1. Again, r dot y2 is going to be more than r dot y1 at all times, but just add an absolute in case something weird happens, And now just return the area, which is going to be the length times the width. I'm going to add a comment there. Area. Boom. Now, the last function we're going to declare is rectangle intersection. And I'm going to call it intersection area, actually. Now, what this function is going to do is it's going to accept two rectangles and then return the area in which they are intersecting. Very useful for our problem right here. So, two rectangles. And calculate the length of the intersection first. So, int intersection length is equal to the formula that I just taught you. So, max 0 and the minimum of the starting points, the end points of the length. So, r1.x2. Oh, come on. There we go. r1.x2, r2.x2. So, these are the end points. Minus the maximum of the starting points. So r1.x1, r2.x1. Perfect. If you don't understand why we're doing this yet, go back in the video and hopefully watch it maybe one more time and you should understand. Now, int intersection width, which is going to be the same thing but for the y position. So maximum between 0 and the minimum of r1.y2 and r2.y2 minus the maximum between the r1.y1, r2.y1. The reason we compare 0 and this chunk right here to see which one is more and use the value that's more is because if this chunk right here is negative, that would mean that the lines aren't intersecting. And if the lines aren't intersecting, that would mean that the intersection area is 0. Okay, cool. Now, all we have to do is return the area of the intersection, which is going to be the length times the width. Perfect. And now, we're almost done. We just declare another variable so that it looks good. So, visible billboard 1 area. So, like the name, it's just the area of billboard 1 that's visible. So we first just get the area of billboard 1 and subtract the area of billboard 1 that is getting covered by the truck. So intersection area, billboard 1, truck. Perfect. Similar thing for billboard 2. Visible billboard 2 area is equal to the area of billboard 2. Subtract the area of billboard 2 that is getting covered by the truck. Billboard 2. Truck. Oh yes, don't forget the area right here. There we go. And now just the final output is going to be visible billboard 1 area plus visible billboard 2 area. Perfect. Now let's test it out. Bam. Run it. No compile errors. Perfect. Okay, now the terminal. I'm going to drag it in here so you can see it. Let's put in the official test case from the actual website. So if we put this in, it should output 17. Okay, let's test it out. Put that in. 17. Bam. Ladies and gentlemen, we have successfully coded the solution for this. Now, if you do follow along with this and submit it to the actual USACO website, you should get 100% in all test case. Thank you very much, and please subscribe if you have the time to do so. It would really help me. Thank you.